Hey guys, allow me to present to you what I believe is the strangest troubleshooting experience I've had to date. Not so much in the way the problem initially presented itself, and the solution ended up being surprisingly simple. No, what was strange was the journey, the troubleshooting process, and I only found the solution through a series of unlikely events that included you, the viewing audience. Well, my concerns have come to fruition. Something is not right with this set. In particular, all the voltages are shifted. Here's what I'm talking about. It's a very frustrating thing about this design is the center tap of the power transformer does not go to ground. If you follow it over, it says minus 120. I'm getting more like minus 220, and where it should be 215, I have 115. Everything is shifted 100 volts that way. So what I'm trying to puzzle out is what sets that. It seems like it's these resistors in conjunction with the load in the set. You can see all these points here. Minus 120, plus 215, minus 120, plus 215. So these all go to circuits in the set. They all draw current, and that, along with the current through these resistors, is going to set these various voltages. So plus 215, that comes right off, well, it starts with the 5U4. We go through the filter choke, a little dinky 10 ohm resistor. I wonder if they intend that as a fuse. It's a little half-watt resistor right up here. And it seems so dinky, but it seems like if the set was drawing too much current, that would go open. I don't know if that was the intent or not. I don't know why there's a little 10 ohm resistor in there. Anyways, it then goes through the parallel combination of the focus coil and the focus control, and then it goes into the set. Yeah, I know it seems like a goofy thing that altering the focus has some effect on the B plus going to the entire set, but design compromises. And then the current's going to go through there and go off to the set, but it also goes through all these resistors to ground and also over to minus 120. Now these resistors are getting kind of toasty. Those are the ones on the back of the set. But this guy, the 850, is not. It's not warm at all. So something is amiss. And the set's not working right either. So how do you track that down? So here's one of the wires I replaced. If that wasn't shorted through the insulation, it was coming pretty damn close. So I thought I was improving the situation, but in doing so, I may have inadvertently messed something up. I think it's more likely that it's not that I wired something in wrong, it's that a little fleck of solder or a component lead that got clipped is brushing into something somewhere. Now, nothing's smoking, there's no hot spots. As I said, the whole power supply from top to bottom is fine. It's just shifted with respect to the chassis. Well, I did find the SAMs. This is freely available from the Early Television Museum's website. And this has a resistance chart, and I very quickly ran into some bizarre readings, so much so I got out 3 meters, because none of them are making sense. I started out with the 5U4, and I'm trying to measure the resistance from pin 2, pin 8 to ground. It's supposed to be 5K, and I'm getting mega ohms. So I'm investigating down the line here, and I've been suspicious of, well, this is where I was doing the work, right? So this point is supposed to be grounded. And they have two 6.8Ks in parallel, then a 1.8K, and then an 850. That's the one I replaced. The original 6.8 and 1.8 are still in there. So if we go from ground chassis, using my fancy HP meter here, and we go to this side of those paralleled 6.8s, 0.1 ohm. It's just the resistance of the leads. That's a dead short. Let's go to the other side of the 6.8. 185, that's not right. 1.6, 1.7. And notice the reading's going up, so there must be a capacitor in series with that. Sorry, connected in that circuit somewhere, and the cap's charging up a little bit. Okay. Let's go to the next point. So now we should be getting 1.8K. Oh, did I miss the lug there? Yes, so now I start getting bizarre readings. What's going on? Now that can sometimes happen when a capacitor has gotten charged up in the circuit. That's been my problem with going through all these 3 meters. Kind of makes me wish I had an analog meter right now, because I suspect that would bleed off the charge because of the internal resistance, but I don't, because I've never had trouble like this before. And if I go all the way back over here, I should have around 3.5, 4K or something, but I have minus 3.6 mega ohms. If I go back over here, it should be essentially 0. It is. Okay, great. Let's go to this point. Should be about 1.8. 1.3. Okay. And then let's go to this point, which is the chassis. Should be ground, and we get minus 3.4 mega ohms. What the heck? But if I take this lead and move it over here, we get 1.6K. And if I take it and move it down to here, we should get around 3, 4K. And now I have minus 3 mega ohms. So I've been going crazy. What I think I'm going to do is disconnect some of these, test them, and I was planning on replacing them anyways. This doesn't make no sense to me. So I'm thinking that there's something very wrong with these resistors, or there's something in the circuit holding a charge that's really fooling all 3 of my meters. Okay, so frustrating though this is, let's see if we can learn something. I have not pulled my other restored AT241 chassis out of the garage yet, but this is a nearly identical chassis, and this one is restored and this one is working. Now let's check the resistance on this one between the chassis and some of those power resistors. In particular, I believe this is the main B plus point here. And the readings do jump around, and that's because there's capacitors in the circuit, but notice it stabilizes at around 5.7K. Let's just call it 6K round up. That's reasonable given the resistor values in the circuit. Let's try doing the same thing on this chassis. So, negative on the chassis, positive. I have this one uncovered, so I can just go right here. 2.75 meg. I've tried 3 different meters. I've tried hooking up clip leads and discharging the caps and all that. There's something else going on. I have checked the individual components by disconnecting leads. Individually, all the components test fine. I replaced all the resistors back here. I get weird readings at a number of points. So this B plus goes between this point, it goes through this resistor, it goes through this resistor, these 2 resistors, and then this wire going to ground. So one thought is, okay, this is an old wire going to ground. Maybe the connection's corroded, maybe it's broken inside the insulation. Okay, cool, fine. Let's take clip lead and go right from this point and also connect it to the chassis. Make sure we get a real good connection on there. Will that make any difference? So back to our B plus point and back to the chassis. Come on, get on there. 2.7 meg makes no difference. Alright, so let's go keep this on the chassis, and let's go right here. This better be 0 because they're both Going right to the chassis. Essentially, we want to jumping around a little bit. Alright, so let's start going back, and let's go to the first resistor from ground to this junction. And that's where I start getting crazy readings, 1.3 meg. How can that be? It's a brand new resistors, one end's going to the chassis, and I'm measuring the other end. How can it not just be the value of the resistor? Let's try the same thing on this chassis. A little bit. Well, I gotta flip things around because the resistor's actually over here. You'll just have to take my word for it. So, negative lead, chassis, positive lead. I think I want to go to this point. Jumps around a little bit as caps charge up, settles in. Around 3.5K. It's two 6-point-K resistors in parallel. That's what it should be. How can we not get 3.5K over on this chassis? That's kind of driving me insane. Let's just do something totally ridiculous. Let me grab a 3.5K resistor. 3.6. And let's just clip one end to ground and just measure with my ohm meter across that resistor. So, chassis, ground, other end of the resistor, 3.6K. Awesome. Now let's clip the other end into the chassis at that same junction as the other resistors, which is right here. And now let's measure across that resistor again. It's 853K now. How can that be possible? And again, let's do the same thing on the other chassis. Alright, resistor clipped in, same place as on the other chassis. Essentially, measure across it. And sure, because now we have three resistors in parallel with each other. It's charging up caps a little bit. It's going to settle in around 1.8K or so. I can think of two possibilities. One is there's something very wrong with this, and every time I install new parts and turn the set on, they're instantly blowing out. The other is caps are wired in like backwards, or there's something wrong with them, and they're not behaving the same. Both sets have been recapped. Both sets essentially have an identical power supply. But before we delve more into that, I want to get out a whiteboard and draw out the power supply and try to explain a little bit how this set works and how we get positive and negative and where ground play comes into play with all that stuff. It's been my experience when goofy situations like this arise, it's either going to be something stupid or something strange. A stupid meaning I hooked up something wrong or didn't connect something at all. Or strange that it's going to be some weird, short, crossed wire, shorted tube, something like that. Anyway, here is a very simplified version of the power supply. Imagine this is the secondary of the power transformer. And we've got one end going to a rectifier, and then to B+, and there would be a filter cap in here. But doesn't go to ground, it goes to this. This is positive. So, there's nothing on the power transformer that goes to ground. One side is what we call B-. It's the most negative voltage with reference to ground in the set. The other side where we got our rectifier is the most positive voltage in the set with respect to ground. We've got this bleeder network. 3 of these are the one resistors on the back of the set, and this one are those fixed resistors, the carbon comps that I replaced, and they're paralleled and seriesed up. We'll kind of call it a lump resistor. It's about 1.8K. So how does this work? Well, each of these taps is going to have a certain amount of load on it, and those are going to return. All the current that's flowing out of these points to various circuits is going to be coming back this way. So all the current is going to be going around this way. I know the electrons don't actually flow that way, but by convention we say electricity flows from positive to negative, so it's all going to be coming out there, the direction of the diode. It's going to be going out the circuits and coming back down here. And of course some of it is going to be going down through these resistors down that way. Okay, this voltage is way more negative than it should be. Say it should be minus 100. We have more like minus 200. And this should be plus 200. But instead, it's more like plus 100. So what would cause a 100-volt shift sort of this way? Well, it's going to be too much current is flowing through these resistors. There's going to be a voltage drop across these. And how do you get more voltage drop across a fixed resistor? You have more current flowing through it. V equals current times resistance. Resistance is fixed, so the only way this can go up is if this goes up. So how can this go up? Well, because this is twice as much as it should be, so there's going to be twice as much current going through these resistors as it should be. What is causing that to happen? Why is everything shift? That's what we're trying to figure out. Now, overall, the voltage across the whole thing is still 300 volts. It's just shifted off. So, seems to be the only way that can happen is if we've got, say, twice as much current flowing through here as what should be. Now, how can that be happening? And also, this resistor, these resistors are essentially cold, meaning I don't think there's much current flowing through here. But these resistors are getting pretty darn toasty. Now that I have another set working and I can feel it, those resistors aren't getting that hot. So these, again, because the voltage is twice as much as it should be, there's twice as much current flowing through here, and power is I squared. So double the current is quadrupling the heat. So let's break it down and do a really simple example. Let's say all the resistors are the same, and let's say they're all 1 ohm. And let's say it's 400 volts instead of 300 to make the voltage easier. We're going to have 100 volts across each resistor. It'd be plus 200, minus 200, right? And it'd be 0 in the middle. So what would cause it to go more negative that way? Would these resistors go up, or would they go down in value to make that happen? Well, let's see. Let's take one of them out. Or, let's go to the absurd example and say this is a dead short, and this is 0 ohms, then this is going to be 400 up here. Conversely, if this was 0 ohms, this would become minus 400 down here. So the side that has less resistance on it is going to have less voltage on it. I think that's the way that would work out. So let's say this became 1 ohm and this became 3 ohms. Say one of these, that went to 0 and this went to 2. We would have 300 volts here and 100 volts there. Now, assuming I didn't put the wrong resistor values in here, that means something out here is changing, meaning the load on this is excessive compared to what's going to this side. And If this was fine, but this had too much of a load, then this resistor would get really hot. And this resistor is cold, essentially. So I think what's happening is we have too much of a load here. I think what's happening is that it's more like this. And something on the main B plus is really drawing things down. So my thought is to sniff around the wiring on this rail and make sure it's not going into anything incorrect. Which is not. Hey, look at that. Nice, solid, clean raster. It's one thing I like about these early RCAs. Pain though they can be to recap when they're working right, they make a really nice, solid, rectangular viewing area. Well engineered. Alright, so, what was the problem? See, I thought about skipping over the problem altogether and just go to the happy ending, but nobody's going to learn anything if I do that. So, yeah, I did screw up something, sort of. Nothing to do with the candome resistors, nothing to do with the electrolytics, nothing to do with the wiring that I replaced. And very much a happy accident that I tracked down the problem, which you may glean from seeing what's on my workbench and what it is. So I posted a video recently talking about cleaning the chassis, and I screwed up editing. I was going to leave a chunk of it out. I accidentally left it in, which led to a comment one of you guys left, which led me to finding the problem. And that was the focus coil. The focus coil was quite corroded, and he said, I wouldn't have messed with that putting in evaporust because you're inviting trouble. I would have just used steel wool on it. I started doing that. I started using naval jelly now because I was wary about dunking this in evaporust, but I got so frustrated that I ended up just dunking in it because everything else was cleaning up pretty well, and there were some areas where the corrosion was deep in there, and I just couldn't get at it. So this is the focus coil that came with the set, still wired in. It's got a problem. And I had ohmed it out right away when I was troubleshooting. I ohmed out the yoke and focus coil, and it's fine. But when I measure the resistance between these leads and the metal encasing, I get several mega ohms, and it should be infinite. So there's something going on inside. There might be some lingering moisture, or the insulation is degraded. Now this set was in a damp environment. I had to remove all that corrosion to begin with. So it's possible it was degrading before I did anything. But yeah, in hindsight, it probably wasn't a good idea. Alright, so first off, let's do some basic ohm meter reading. So let's go across the two leads. It should be several hundred ohms. 265, 268. That's right about what it should be. Now let's take a pointy bit and stick it on the metal casing. This should be infinite. And we get a reading. And it's weird. This is negative. Why is it negative? I don't know. Well, if I go the other way, will it be positive? Let's see. It is, but it's even higher resistance. What I think is likely happening, as one of you mentioned, is that evaporust is a chemical solution, and there's probably some in here, and it's forming a chemical reaction. So we could be getting a galvanic electrolysis action. It could even be acting like a sort of battery. And this itself is doing weird things. And this is only putting a few volts on it. When it's in the set, the potential across this is a couple hundred volts. So whatever's happening with this is going to be happening on a much larger scale with full voltage. All right, let's go back to our simplified power supply diagram. Where would that focus coil fit into this picture? Well, it would go in right here, and it would act as a filter choke on the power supply. Now, if the issue was we had a short return, some leakage between these windings, then the effect would be probably not that noticeable out here. Maybe this voltage will go up a little bit or down a little bit, but it would affect the magnetic field, and you probably wouldn't be able to sharply focus the image on the CRT face. But that's not the whole picture, because this coil sits inside a metal container, which is attached to the chassis, which means it's grounded. Now, if we have a lot of leakage between this coil and that container and going to ground, that's going to be a problem. And since this voltage is about half of what it should be, I'm guessing that equivalent resistance is equal to this resistance. So this total, let's say it's 3K. I think we got about 3K leakage here. So it's the equivalent of having an extra resistor here that's 3K. Which means, yeah, we're getting a lot more. And it's getting stolen up through another part of the circuit, robbing it from this, which is why this resistor is running cold. But that ground, it's going connected to this ground, which means it's all going through this. All power is still going through, all current is still going through these two resistors, which is why they're getting quite toasty, even though that's cold. If I ran this set longer, I bet that would start getting warm. I never had it on for very long. So I think that solves that. Now, what about the meter reading, where we're getting negative 3 mega ohms and just crazy readings, or positive 8 mega ohms? Well, when you're using an ohm meter, it's only putting, 1-2 volts across this rather than 100 plus volts. So I think we see a very different reaction then. I think when there's 100 plus volts, it's conducting. When it's maybe only 1 or 2 volts, maybe we're getting some kind of weird electrolysis galvanic reaction between metal surfaces and a conductive solution, and it's acting maybe like a battery. And if you ever use an ohm meter, a digital ohm meter especially, on a circuit that has some voltage on it, you're going to get crazy readings like I've been getting. So I think that explains what's happening. I hope you found this interesting, or at least confusing. I know I sure did. All right, next time, what are we going to do about this? We need a focus coil. Either have to repair this or replace it. For sure, we're going to try to open it and investigate it further. Stay tuned.